The last flip-flop that we have to study is our T flip-flop. We have completed SR flip-flop, D flip-flop and JK flip-flop. When we have to only store the data, we use D flip-flop. In JK flip-flop, we overcome the not use state in the SR flip-flop, that is 1-1 state when your S is 1 and R is 1. And in that case, we are having the toggling action. And the toggling is the control change of output from 0 to 1 and 1 to 0. This is something we completed in the last 2 or 3 presentation. Now if I ask you one question, what if I only want toggling action? In that case, we will use a flip-flop we call as the T flip-flop. This T stands for toggle. So definitely we are going to use JK flip-flop to obtain our T flip-flop, like we used SR flip-flop to obtain our D flip-flop. But in D flip-flop, we complemented the input. In this case, we are not going to do that. We will just give the same input like this. J and K are same always, and this I call as T. And this is our clock. So this is a very simple flip-flop we call as the T flip-flop obtained from the J flip-flop when we make J and K as the same. Okay, in case of D flip-flop, we were having SR and we complemented the R. Now let's see the truth table for T flip-flop. We are having clock T as the 2 input and Qn plus 1 as our output. Now when clock is low, definitely the flip-flop is not going to operate and the state will be stored. So whatever be the value of our T, the Qn plus 1, the output is going to be Qn, that is our memory. It's well known to you. And when the clock is high and T is low, it means again we are having memory, because J, in this particular case, we are having J as 0 and K as 0, and whenever this happens, we are having the memory. It means whatever be the previous state is stored, and the Qn plus 1 is equal to Qn. So again we are having memory state in this case. Now what when the clock is high and the value of T is 1? This is what we are looking for, because when T is 1, J is 1 and K is 1, and this is the case when we are having the toggle action. So the output will be Qn complement. This is my toggling. So this is all that we have to see in the truth table of the T flip-flop. In the next presentation, we are going to have the characteristic table and the excitation table of the T flip-flop, and after that we can move to our flip-flop conversions. So this is all. See you in the next presentation.